Welcome back to AP Stats class. This is the second video of 6.3. You'll have one more video on Wednesday. So we're going to review the formula that you learned in the last video. And we're going to scroll down to the in general, how can we calculate part. Because we learned that the formula that's on the formula sheet is n choose k times probability of success to the k power times probability of failure to the n minus k. And this n choose k, that notation was n choose k in the calculator. If you go to math probability, you'll see it in the options. And so n is the number of trials, and k is the number of successes. So let's do a couple practice problems. In many games involving dice, rolling a 6 is desirable. The probability of rolling a 6 is 1/6. X is the number of sixes in 4 rolls. Then X is binomial with n equals 4. Probability of success is 1/6. So if I want to know the probability that I get 0 sixes in 4 rolls, then it would be 4 choose 0 times the probability of success 0 times, and the probability of failure 5/6 to the 4 times. So I succeeded 0 times and I failed 4 times. Well, 4 choose 0 in the calculator is just 1 times 1/6 to the 0 times 5/6 to the 4th. So that's just 1, that's just 1. So now 5/6 to the 4th is 0.4823. So you can do the same thing for what if I wanted to know the probability that I land on 6 one time out of 4 rolls. So that would be 4 choose 1, and I succeeded 1 time and failed 3 times. So that ends up 4 choose 1 is 4. So I've got 4 times 1/6 times 5/6 to the 3rd, and that is 0.3858. And I could keep going and going for each of these, right? I would just do 4 choose 2, 1/6 squared, 5/6 squared, or I could do 4 choose 3, 1/6 to the 3rd, 5/6 to the 1, and I could do 4 choose 4, 1/6 to the 4th, 5/6 to the 0, right? I could just keep going. Now, what if I wanted to know the probability that it's less than or equal to 3? Well, I would have to do probability that it equals 0 plus probability that it equals 1 plus probability that it equals 2 plus probability that it equals 3, which is tedious. That's not how you spell tedious. Tedious. So we're going to use the calculator. There are 2 functions in the calculator that will help you do this. And I already put a video in the margin of your online learning topic that goes through how to use the calculator. And so there's 2 functions. There's 2 calculator functions. The first one is binomial PDF. And you plug in NPK. That is for probabilities where it's x equals a number, where n is the number of trials, p is the probability of success, and k is the number of successes. That can be found in the second VAR's menu. The second calculator function is if I want to know less than or equal to, like what is the probability that at least 8 or at least 4, and that's binomial CDF. Same menu, CP or NPK. And that's for probability that x is less than or equal to k. It can only be less than or equal to. If you end up doing a probability that's less than, then you've got to rewrite it. So for example, if I want to know the probability that it's less than 10, okay, these are discrete functions. So what's the next number less than 10? Less than or equal to 9. So you've got to rewrite x less than 10 to be x is less than or equal to 9, and then you can use the calculator function. If you've got probability x is greater than 10, the opposite of that is less than or equal to 10. And if you're finding the opposite probability, then you do 1 minus. And if you're trying to figure out x greater than or equal to 10, the opposite of greater than or equal to 10 is less than or equal to 9. So you've got to rewrite all of your probabilities so that you can use this binomial CDF function. Because the binomial CDF function can only be used when it is a less than or equal to. And with anything used in the calculator, you have to label all your variables, state, plan, do, conclude type of thing. So let's look at part A of this example. It says, in roulette, 18 of the 38 are black. You're going to spin 10 times. What is the probability that 4 land on black? So the probability of success is 18 out of 38, which means the probability of failure is going to be 20 out of 38. So if we were doing that by hand, we would need this information. We're going to spin 10 times, and we want 4 successes. So they want to know the probability that 4 of them land on black. Well, we can use the by hand formula, 10 choose 4 times 18 out of 38 to the 4th times 20 out of 38 to the 6th. And when I type that in, I get 0.2247, because you would use 10 choose 4 in the calculator. Or I could use binomial PDF, where it does all of this for me, where I've got 10, 18 out of 38, and 4. And that will also give me 0.2247. So it's a lot quicker, it'll save you some time. Part B, it says, what is the probability that at least 8, so x is greater than or equal to 8. Well, I can't do that in the calculator, so I'm going to rewrite this to be the opposite of greater than or equal to 8, which is less than or equal to 7. So 1 minus the probability that x is less than or equal to 7. And so I'm going to use binomial CDF. The C stands for cumulative density function, and the P stands for probability density function. So this will be 1 minus binomial CDF, 10, 18 out of 38, and 7, which is 1 minus 0.9615, which equals 0.0385. So those are the two ways you can use your calculator. If you need more examples using the calculator, then watch the calculator video number 2 in the margin of the online learning topic. Make sure you're working on some of the homework problems practicing this. In the next video, we'll talk about the mean and standard deviation of binomial variables as well as geometric variables. Don't forget to stop by my office hours if you have any questions.